Welcome to section 15.1, Formulating Statistical Questions, Gathering Data, and Using Samples. In this section, we'll be covering these topics and these objectives, these standards, vocabulary, and concepts. So when we think about statistics, this next section here, we can think about the fact that we are naturally curious about each other in the world, and we want to know what others around us think about maybe what TV shows they're watching, music, political questions, local, state, and national governments want to know facts about population, employment, income, education to design appropriate programs and make decisions. Scientists want to know how to cure and prevent diseases. Therefore, all of these organizations regularly design investigations and gather data to help answer specific questions. So according to guidelines for assessment and instruction endorsed by the ASA, we have 4 components to statistical problem solving. We need to formulate questions, collect the data, analyze the data, and interpret the results. So in this section, we're going to start by examining the first 2 components, formulating questions and collecting data. Then we'll turn our attention to analyzing and then interpreting. So first, let's start with what is a statistical question. So we first need to formulate a question that can be answered by collecting and analyzing data. So if I just ask you, is it going to be sunny today? That's a one-word answer. There's no data there. And another distinguishing characteristic of statistical questions is that they anticipate variability, which means something different. So we don't expect all backpacks to weigh the same or all names to be the same length. So if it's a statistical question, it's going to take into account things that are different. And we'll analyze this a little bit more. So there's 2 types of data that we'll be discussing here. That's numerical and categorical. So if you look at the roots here, numerical sounds like number and categorical sounds like category, and you would be correct. Data that's numerical is data that is a number, such as weight, height, volume. Categorical data cannot be added or subtracted. So colors, yes or no, favorites. So there's a variety of statistical questions. So if we were planning a party, we might like to know favorite snacks. If everyone in class received a small packet of candies, we might be curious whether they contain the same number. So whereas the favorite snacks here is going to be categorical, the number of candies is going to be numerical. Let's take a look at an exploration. Remember, don't skip these. Take your time. Press play when you're complete. So pause here on this You Explore, and then we'll go over some examples together. Determine which of the following are statistical questions. Explain why the others are not. How many pages do textbook have? Well, how would I answer this question? I might say, okay, maybe 150, maybe 200, maybe 400. So there's variability here, and we could ask other people and collect data. So this is a statistical question because we can collect, analyze data, and there's variability. How many pounds of plastic did your family recycle last year? Well, if I were to ask that question, your family, maybe they're asking my family, and so I would give a single number reply. Well, there is no variability there. I didn't have to collect or analyze any data. It's just one number, so this is not a statistical question. How many emails did you receive last week? Well, I could answer that question. It would just be me answering that question. The answer would be a single number, so this is not a statistical question. How often do people travel to other countries? Well, people. So I would have to ask, maybe some people would say once a year, maybe people would say once every 10 years, maybe someone would say one time a month. So now I'm collecting, analyzing data, and there's variability, so this is a statistical question. Let's do this again. Your class of 5th graders are experiencing growth spurts. Which of the following are statistical questions for the situation? How much have your students grown in the last month? How tall is your tallest student? How tall are your students now? All right, so how much have your students grown in the last month? Well, for me to find that out, I would need to ask the students, So maybe someone would say 1 inch, maybe someone would say 2 inches, 5 inches. So this to me seems like a statistical question because the data is going to vary. I have to collect and analyze it. All right, what about how tall is your tallest student? Well, I would ask around, but there would be a single answer. And so this is not a statistical question. How tall are your students now? Well, some might be 5 feet or 3 feet or 4 feet. So this is a statistical question because I have to collect and ask all the questions and the data varies. Go ahead and give these 3 problems a try. Press play when you're ready to see the solution. There we go. There are 2 basic types of statistical studies, observational studies and experiments. Observational studies observe characteristics and quantities. So they're just observing them, but they don't attempt to influence them. So for example, in an observational study, they might count the number of turtle eggs found in a certain area. They might measure the height of a plant every day or collect participants' responses to a questionnaire. Writing survey questions to learn facts about people or determine people's opinions may seem like a simple matter, but it's surprisingly difficult. Different people may interpret the same question in different ways. How many children are in your family? Does that mean under the age of 18? Does it mean how many siblings plus yourself? So a good survey question must be clear. Experiments. So in contrast to observational studies, researchers don't simply observe. They try to determine if certain factors will influence. So for example, to determine if a new drug is safe and effective, a group of volunteers will be divided into 2 or more groups, one receiving the drug and the other receiving the placebo. Data is collected to determine how effective that drug is. So in observational studies, we're not changing anything, we're just observing, but in experiments, we are changing factors. Now, populations and samples. So regardless of whether it's observational or experiment, a statistical study focuses on a certain population. The population is the full set of people and things that the study is designed to investigate. For example, before a presidential election, a study might investigate how registered voters plan to vote. And so the population is only registered voters in the country. Not everybody in the country, but only those registered to vote. Another study might investigate properties of ears of corn in a cornfield, and in that case, the population is all ears of corn, but only in that cornfield. They're only concerned about that, not all ears of corn everywhere. In most cases, it's just not possible to study every single member of the population. For example, if we go back to this population, all registered voters, it might be really hard to get every single registered voter to answer a question. So instead, we choose a sample to represent the population. A sample of a population consists of some collection of members of the full. So a pollster will select a sample of voters to survey how they will vote in an upcoming election instead of trying to ask every voter. A scientist might study those ears of the cornfield and just select a sample of the corn rather than every single ear of corn in the cornfield. Go ahead and explore here before we continue forward. So if you did the exploration, then you probably realized that some samples may not accurately reflect the full population. And the best way to pick a sample so that it will be likely to reflect the full population accurately is to pick a random sample. So for those cornfields, right, if we've got a field of corn and our population is all the corn, a random sample would not be every corn in this corner here, because maybe that corner gets different sunlight than back here. So a random sample. Same thing if we were kind of thinking about the United States. Oh boy, right? If we only pick a sample from, say, right here, then we're not going to get a representative of the full population of everybody. So for a sample to be useful, the characteristics must reflect the characteristics of the full population. So it should be representative of the full population. But unless you choose a sample carefully, the sample's characteristics might not be representative. So for example, if a group studying child nutrition in a county took their sample of children from a school in an affluent neighborhood, the findings might not be the actual nutrition of the entire county. So the best way is to pick a random sample, choosing the sample in such a way that every member of the population has an equal chance of becoming a member of the sample. Sometimes students may interpret random sample incorrectly as a sample that is chosen in kind of a haphazard way, but actually random samples are very systematic and algorithmic. So say there are 100 students in the 7th grade and a random sample of 10 students is to be chosen. Although Johnny may have an unusual method in mind for picking the 10 students, the method won't produce a random sample unless each student is equally likely to be chosen. So a simple way for students to pick a random sample is to cut a list of students' names into identical slips, put them in a bag, mix them, and then pick exactly 10. And the slips of paper could instead be numbered from 1 to 100, and then each number corresponds to a student. That is a way to pick a random sample. So in settings where the population is too large to maybe do a slip of paper like every registered voter, random samples are often chosen with the aid of random number generators by computers or calculators. And we'll pause there, and when we come back, we'll do some examples.